now streaming. And go. Okay. Last day, we started talking about reaction steps and intermediate steps and looking for the different steps of a reaction. We did the demo making with methane. It turns out Felix and Sophia were the weakest link. They were what's called the rate determining step. And if we have a one-step reaction that has a very high activation energy, we might be able to lower that activation energy, increase the number of steps, but if we lower the amount of energy, it will go faster. And now we are going to analyze a multi-step reaction. So this is the overall reaction. Is it balanced? No. You can balance it now, see if it matches, but oh, there's drawing on the board. I'll fix that. But what I would like you to do is we're going to take down these elementary steps. So the first reaction is going to be HBr plus O2 goes to Huber. Second reaction, carbon plus HBr plus Huber makes 2 Hobers. And then 2 HBRs plus 2 of our Hobers makes 2 waters and 2 bromine gases plus carbon.
2BR2?
Yep.
How do you know how to do that?
I have given it to you.
Where did the carbon come from?
Yeah, where's the carbon come from?
Yeah, true.
Right here.
But like, how to get
Where
there?
is it?
Something. Oh, magic.
What happened to it?
This is like biologists when they add an enzyme, they essentially say a miracle happened and the reaction went. So if we add something and then it pops out unchanged, what is that? Catalyst. Maybe that C wasn't for carbon. Is my clever way of saying that's a catalyst. So would that cancel out? Yeah. So we would take that and go, oh, that cancels out. That is a catalyst. Have you done previous in your pre-calculus algebra experience like three equations, 3 unknowns, 3 equations, 2 unknowns, and you calculate things? And so you're used to like adding equations? I would like you to add these equations. Cancel the things that are the same on opposite ends, just like you would an algebraic equation, and get an overall equation. And then I will use that time.
On opposite end?
So use the arrows a bit like an equal sign, although it pains me to say that. Because if any of you write an equal sign on your tests or quizzes instead of an arrow, I won't say that I'll shoot you, because that would be wrong. But it will greatly irritate me. As a question, why can't you put an equal sign there? Why don't we?
Because it doesn't.
Yeah, they're not equal. So when you use an equal sign, it's just that's why it's wrong. There's a transformation process.
Do we add the specific elements together, or
we add the compound?
You do treat it like X's and Y's and Z's and how you would eliminate.
Oh, you
things.
just get the big one again.
So
Like the top one.
So you can't eliminate like the oxygen from here and the oxygen from there. You can only eliminate a Huber and a Huber. They have to be the same molecule.
I love
Wait, we're
eliminating.
going down or across?
Both?
What? Uber.
What do you mean down or across?
Like,
What kind of crazy math are you kids doing these days?
you like go down.
You're gonna have an arrow here. Let's do it together. What's something we could cancel?
Huber.
Huber. Huber
Huber and Huber.
Oh wait, on the opposite side of the
are on opposite sides,
Oh, I get it now.
so they cancel out.
Wait, so then what about the HBR? Would that
Ooh, what would you do with the HBR?
would that be
Keep
for
it.
HBR?
For HBR. That would be a great name. Whoops. Great name for a company. I need to go catch a Huber.
I came up with this really cool idea.
No,
about-
no, no, stop.
It's not gonna catch.
I can tell that's not chemistry related at all.
Think about
I thought everything was chemistry.
It is, but some is very distracting.
So
Notice it also didn't stop him.
there are two categories in life:
Yeah.
chemistry and distracting.
No, chemistry we're learning, and chemistry we're not learning. It's like when someone's sitting in physics class and they throw a paper airplane. They say, "Don't do that." You go, "But it's physics." Technically, it's chemistry. It's still distracting. No, stop. No, stop. What else cancels? Hober. Ho ho hober.
And catalyst.
Now, are these catalysts?
Yo.
No, it's a product. It's actually made. This wasn't made. We put it in and it popped out. So that's how we know it's a catalyst. But this is made and then comes out. This is made and then comes out. This is known as a reaction. Intermediate. And how you identify them versus catalysts is that they're made and then they're used up. So they have this directionality when you line it up. Whereas a catalyst crosses that. They have a different directionality. They are put in and they can be put in any step. The catalyst could have been put in the first step, pops out the last. It can be put in the middle step and pops out the middle step. That catalyst can pop out anywhere. And it can be put in anywhere, but it has to go in. It's added as if by magic. Because literally, the great god or goddess of the chemistry lab just went catalyst and made it happen. So, is there anything else on this side? What's not crossed out?
O2.
O2. Oops, wrong color. There. Oh, there it is. There we go. What's left over from this side? 2H2O plus 2Br2. Okay.
This is a really long
And
way of
it's now balanced. Pardon?
This
NA?
is like a really long way of balancing a formula.
No. What this is that all this that we've previously been supplied with, or even this, which is a balanced equation, is not the actual reaction. Many reactions that we observe, particularly because now that we can see this, we can see that this reaction properly balanced is this. And we've already established that there's a low probability of multiparticle collisions, and intermediate steps only have two particles at a time. Notice, two particles, and a catalyst holding them together, two particles. This reaction doesn't happen that way. And anytime you see more than that happening, there's a multi-step reaction. It's just they all happen quickly enough that this is the product that sticks around. So you're not going to see these unless you do something fairly fancy. This is fairly important in biochemistry, because if you're doing a reaction, these intermediates actually can go off to multiple different products, and you might be interested in stopping the reaction here and talking about Hober. And maybe Hober goes and makes something else for a change. What I would like you to do with Hober is I want you to draw the potential energy diagram of this reaction on this page and assume it is exothermic, and assume that step 2 is the rate determining step. I am going to come around and look at what you're doing.
And the second one he speaks.
Yeah, exactly. Oh, that's only one, so that's a one-step reaction. That's actually 3 and then 4.
Sorry, this was a bias.
Yeah,
Sorry, that was
yeah.
hyperpolarization. God damn it, I'm trying to buy that. Please ignore me. Okay.
Oh, yeah, that
Sorry,
works.
man, that was hyperpolarization. Please ignore me.
1, 2, now, but you don't have the second step as the rate determining step. No, but you do, that's good.
Taller? Taller.
That is 3 steps, that is good, but it's very on your first step, not a rate determining step, like your second step. Oh, and you need to keep working? No, you can figure it out. Just make it your second step, not your first step. That's only one step, that's only one step. What? I don't know, ask other people. They're doing fine, they seem to do well. Yeah.
No, I have one.
That's only one step, that's 2 steps. You need 3, and the second one has to be the rate determining step. Now, you do have the second one as the rate determining step there, but you need 3 total steps. Because our previous reaction we just did, how many steps did it have?
It's Colbert.
3 steps. That looks really good.
Wait, how is this the rate?
Oh, I admit it, that's only 1 step. You need 3. That's only 1 step. You did 3. Did you draw in pen? What is my next step? So do it below in a different color. And what would it look like if you had 3 steps? There you go. Yeah. Like this. And the second one's your rate determining step. Excellent. And it's exothermic. Well done. Hooray! I already looked at yours. Yours are all good. And you changed yours. That is good. And old, is it exothermic? Yep, it technically is. Yep. Yep. Excellent. 1, 2, 3, and the second one definitely is the rate determining step. Yeah, and we're up to yours. Anybody who I haven't seen that would like to double check? Perfect. And it's exothermic, and you have a rate determining step. You have 3 steps. The second one is not the rate determining step. Technically, I think only your first one is the rate determining step. Same. Now you have 3 steps, but the second one has to be the rate determining step. Bigger. The rate determining step is the slowest. Because it says, assuming step 2 is the rate determining. So I told you it had to. No. We're
driving your car.
already started. We're grinding. Yeah, we're grinding. No, just grinding. We're grinding. Nope. No. Yep, yep. What? Sorry, what? No, 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 I just heard you said. Oh, most reactions, even if they're multi-step, will happen very quickly, and you just see the products in the reactor. I'll take a look. I don't think I have a lab that does that, but I'll take a look. Yeah, no, I'll see if I can find one that shows it, because I didn't find where we were entering the complex. That took me a few years to find. I did find it. Yeah, you can see all the different steps. Yeah. Okay. If I can get everybody's attention back. Nicholas. We got Eshwan, Taylor, Dylan. Excellent. Please label yours. You can keep yours. You don't have to draw it to look like mine. So just to label it now, we're going to go there. And then I'm going to make mine like this, that, and then this. And that looks like a really weird peak.
Yeah, looks like a Nightmare Before Christmas.
Yeah, and it also kind of looks like it's fingering people. If I was to that, do the color like this. Using these marking points, you can now show that every one of these. Nick?
Wait, why does mine not look like that?
You can draw it differently. Is your second peak the tallest? Or,
Yes, second.
then that's good. We have the first activation energy, the second activation energy, and the third activation energy. 1, 2, 3. Dylan, do you need to step outside for a moment?
No, I'm just trying to get Luca to come.
Trying to what?
I'm trying to drag Luca here.
No. It's much quieter.
Oh, really? Because we left her saying we were doing something really confusing. I said to her,
No, I don't need, no,
Okay,
no,
I'll show you
no,
after, I'll show you.
yeah.
it's really funny.
Okay. A few things that we can say is that our second activation energy is greater than our first activation energy or the third.
Wait, sorry, excuse me. Why does the activation energy of the tallest peak not go all the way down to
Oh,
the valley there? Like all the way down? Is that supposed to be it?
it did all along. I don't know what you're talking about.
Okay, yeah,
Yeah.
for sure.
Because it should have. I just saw that first line and stopped. My mistake. Because it should always go from where it's starting from, and it was starting from here, and then it went all the way up. This one's starting from there, so that one's right. This one's right. That one, however, was wrong. Thank you for that correction. Question, Nick? I thought you went like that. Did you? Yeah?
Wait, how do you know, how deep the curve?
Oh, if you were given the numbers, like this activation energy is 20 kilojoules, this one's 50, and that one's 25, and it starts at, I don't know, 80 kilojoules, then you could do it, right?
But for this graph,
But for this graph, it's qualitative. I didn't give you any actual numbers. So I'm just, all I look for is that your second peak was larger to illustrate the point, not for specifics. Yeah. Speaking of, yes?
The last activation energy, not little equation, say activation rate.
There. Thank you. And that's what makes it the rate determining step. I also just realized I haven't done attendance yet. So please bear with me, because someone's going to get mad at me eventually. Chloe, Martin, Luca's at climbing, Felix, Nicholas, Taylor, Eric, N.A., Eshwan, Luce, Sophia, Teddy. Teddy?
Yeah.
I think I have, see me after, I think I have something of yours. Dylan, Sabine. Thank you for coming to class. You're not supposed to be on a bus somewhere, right? Okay. Inara and James. So, Eric, what determines the rate of reaction?
Is the one that requires the most activation energy.
Yes, the one that requires, that's the rate determining step. But just in general, how can you, just by looking at a graph, how do you gauge its rate of reaction? Pardon?
This is slower.
Which one's the slowest?
The biggest one.
The biggest one. What is it biggest in?
It
Takes a lot of energy. So another way of saying that rate is proportional, hold it. What's the mathematical sign for inversely proportional?
No idea.
Oh, I know. No.
It's proportional to the reciprocal.
Proportional to the reciprocal of the activation energy.
What?
I've never seen that in my life.
Oh, beautiful. If you don't like that, another way of saying that is
What does that fish mean?
Yeah, I was thinking something.
this
Yeah, what's that
I've
mean?
never seen like
proportional to?
Oh,
Like,
never learned.
like I use it all the time in my schools.
like if, what are things that increase? Soda consumed is proportional to temperature. The hotter the summer, the more soda is consumed. Proportional to means they both increase at the same rate. If you did 1 over, you would say inversely proportional to, and that would mean the higher the temperature, the less soda was consumed. You don't do that in math?
No, we use
I've never seen that in my life.
No. Well, wait till university.
Well, I was
I'm not going to be doing
What's
that.
the difference between that, like the fish and the
I feel like those
cosine?
just never
Alpha sign?
keep my options.
Yeah, the
Proportional is just the alpha sign is just used to mean proportionality. There's no difference.
Oh, no difference?
No.
So I can use equal sign and it will still be correct.
No, because equal means exactly equal. Are you talking about this sign?
Equal means the same.
No, just like the straight two
No, but you know what that means, right? And you know what that means?
Yeah.
If this means is there, it means exactly equal to.
Oh, okay.
In chemistry, you would never use that
Oh,
because the error is in our sig figs, so we never say approximately,
okay.
right? Approximately is used when you don't know the significant figures, and it could be anything. So if you don't like the little formula there, you can say high activation energy means slow rate. Low activation energy means fast rate. And if you recall, this is actually one of our PLOs in section A. We drew rate and we had activation energy in there. Now, I think there's a blank page here somewhere. Yeah, right there. Cross that out because I'm not going to use it for this anymore.
Wait, can you go back there?
Yep. Sorry.
Okay, I got it.
Okay. Go to this page, cross that out. What I would like you to do is I've got two reaction. A goes to B. And I've got C goes to E. This is the overall. 2 pages from now. It says what is the slowest step at the bottom? Just cross that out. There. Because we're not doing that. It's after this page. I'll go back to it. Don't
What does it
panic.
say next to C?
I just want to do this first.
Overall.
Okay? That's the overall. It has 2 steps. C goes to D, and then D goes to E. I would like you to graph below these a rough sketch of the potential energy graph.
Which one is the rate determining step?
Doesn't matter.
Exothermic, endothermic.
Actually, why don't we make it matter? Which one do you want to be the rate determining step?
Second.
Hands up for the first one. 1, 2, 3, 4, 5, 6, 7. How many for the second one? 1, 2, 3, 4, 5,
Okay, we lost.
6. Oh, so it's the first one.
Exothermic or endothermic?
Ah ha ha.
Are they exothermic or endothermic?
Ooh, should we make it exo or endo?
Exo for the first, endo for the second.
No, they have to both be the same.
Okay, endo.
Endo, endo. Go. Sketch those. So we have a 1-step and 2-step reaction because there's something very specific I want to make sure I address.
Wait, was it the first or the second?
It was the first.
I didn't understand that sentence. Who said that?
Wait, so
What did you say?
is it the first or the first or the second?
It's the first.
That has to be right.
First.
Reaction determining step?
Yeah, right here. First step, rate determining step. You already asked.
This is crap.
Yep.
So rate determining.
Although you keep asking for assurance, I should stop giving you.
Wait, what about
You just be confident.
What's the rate determining step in this one? Number one, right?
Number one. Number one. You do need that to figure it out.
Number one.
Yeah. There you go. First one's rate determining step. You got 1 and 2. Go. Compare to people around you, see if you got it right.
Why is mine keep looking up? What is that?
You've seen how I draw, right?
It looks like a pool.
It's like the one for you in my life. This class, I kind of know what I'm on.
So it's like,
Actually triggered.
wait, so it's like this.
But I said we all have questions like this.
Yeah, the lines are just very close together. They're very small delta H. Oh.
We all have lots of questions.
Yeah, that's what I'm gonna do. Yeah.
Okay, and just tell us.
But I want to illustrate something that you previously learned that I don't want you to get confused about.
So I can't explain. I tried to tell Luca to come. I said I lied to her though.
No, I'm just gonna put it up front. I'm gonna put it up front. I'm not gonna look at it.
The card name. You got the card name.
I know. It's so awkward.
There we go.
Okay, yeah. But, I said we were doing molecular logarithmic approximation of.
That is.
Yep, except it wouldn't stop there. That one, if you go from there to there, this one goes from there all the way up. That's
I need
why
to see what she said.
It goes right from where it begins to where it ends. Does that make sense?
I'm like, shit.
But
The activation energy.
no, you needed 2 peaks. That part was right. What I'm saying is that you stop this here, but it starts here, right? So it's gonna go all the way up to there. Okay? And you do need the second peak. What you had there was correct. Yeah. Which is that part. You guys good?
Higher energy capacity.
Yeah.
Oh,
Yeah.
I have a question.
Good.
Back down.
No, and the thing has to be higher than that.
I know, but like, not at the end. Like,
Oh, no,
We'll try to be efficient, so we have to
it's somewhat arbitrary. It has,
Why?
This
Because I
is
gotta go
whatever
there.
the stability of D is.
No, just go.
Let the ends put
Go
the
after.
bonds.
No, because I have gym.
And we're just making up.
We'll end it. We'll end. You can go get dinner.
But no, I don't want to. I'll just.
Okay.
But there's no.
It's bad. I need some extra.
Excellent.
I have no more devices left.
Yes. Oh. Did I not already get through? Okay, good. Good. Yep. Good. Good.
We use walkie-talkies.
Good. Good. Is that above? Yes, it is. It's a little bit above.
Wait, I think she knows them.
Okay.
She can hear me through the microphone.
So, what you should have, and what everybody does seem to have, now label these. You will have them, this goes from A to B. You will have some version, now the first step was endothermic, so it's going to go like there, and then there, sure. This has a delta H that's positive. If we were to delta H positive, delta H positive, and we would start off with C, D, and E. Now, D is made and then is destroyed. What is D called? Flip it the other way. Yeah, it was a little Yoda there. Reaction intermediate. Or to go with Yoda, intermediate of reaction.
You've had some better.
Why did the Star Wars movies go 4, 5, 6, and then 1, 2, 3?
Because.
In charge of scheduling, Yoda was.
See, that one was better. See, that one was good.
Is that good?
That was better.
Is that better? Okay. Skill testing question. What is the thing that's up here called? Remember, up here you're going to get what? Now, first of all, what's the formula of the thing that's up here? That's some sort of AB thing. What's that called?
Activated complex.
Activated complex.
See, we have this.
The activated complex is at the top of a peak. It's really unstable, and then it comes down to a product.
Where do you get it on the multiple?
So on the multiple one, you would have some sort of CD here and some sort of DE here. These, it would have two activated complexes. They are not reaction intermediates. And because they both take place in between, sometimes students would mess these up. So I wanted to make sure I got them both on the same page and you could see the difference between the two. These are at the peak. Whereas, let's go there so we can highlight it properly. Whereas these, blue might not be so great on blue. Let's go with pink. These, the reaction intermediates, are in the valleys. There's similarities that they both take place in between the reactants and products. But they are called different things and they have different chemistry. The reaction intermediates are a lot more stable. They're in the valleys. You can sometimes separate them out, especially if your reaction is incomplete, and so on.
They actually call it that. Yeah, I was thinking it was called something fancy.
What it was?
Values.
The-
Isn't it like the vertex or something?
You're getting all mathy now.
Oh.
It's a valley.
Oh.
That's a peak.
Okay.
Don't you call it that in math?
No.
No, it's the vertex or.
What's down here?
It's like the point in your shape.
Yeah, true.
Like on
Relative
the
minimum.
Like in physics.
Yeah, relative minimum,
Relative,
maximum.
relative. Okay, so okay, it's at the relative maximum.
That's much better.
Relative.
But that just is the maximum though, because there's no like, it doesn't go off anywhere. It's not a graph.
And this is the relative minimum. But since I have adopted some of your crazy math terms, I am now requiring you, next time you're in class and you're seeking towards an answer, you must ask your math professor, how many sig figs should this calculation be done to? Yes.
But also crest to trough.
Oh, crest and trough would easily work, yeah.
I think
Yeah,
I've tried
physics.
to say this once before. Try to explain this.
Okay? Now I'm going to go back to here. Anybody still getting this down? Okay, back to here. Who are our two slow people? Felix and Sophia. The rate determining step. We're going to formally define it. It's the slowest step. And it has the highest activation energy, or energy of activation, Yoda says. I'll cross off above. Previous Huber.
That's going to be my job.
Can we see what the
my
auto
job
thing
description.
was?
Sorry?
Can we see what the auto spell?
Yeah.
That's going to be my job description. Previous Hoover.
Let's see.
Whoops.
What?
Previous, oh, it's going to be some feral, vile stuff, right?
It's a period Hoob.
Period Hoover is crazy.
That's the best thing ever.
At least they got a Hoob out of it, so. Yeah.
Wait, can we take a picture now?
How many steps did that reaction have? 3.
Okay, so what is that? Previous Hoover, right?
Yeah, because it said the above reaction. I'm like, we're now 3 pages in. You probably have forgotten that we were talking about this reaction. Oops, where was I? There. Okay.
Have you ever been a current or are you a current or have you ever been
Stand up.
I follow orders blindly.
Excellent. Well done.
I'm really scared.
Shake your legs. You have 5 minutes.
Shake my legs.
You have 5, not to shave your legs.
Shake my legs.
You have a 5-minute break.
Let's go.
Let's actually.
I
Just for the break. Can I use this for the break? Because we're technically on a break.
No.
Can I use my computer?
No, what do you mean?
Do you want to see my labs?
You want, yeah, I can answer some questions.
I am not, nor have I ever been a Hoover.
Okay. Everyone knows. You'll get a real. And it,
Yeah, I just gotta.
I would do another lab. if you do better on the next one.
You don't even
If I
need
do
good.
better on this
If you
one,
get a time
then I
on
It'll always count.
favor this one.
Yeah,
Yeah.
maybe then it would take 5 days. That sounds
Okay, that
like
one's a pocket, so they're not snap for sure.
you can also be real quick. Yeah,
I think I have like,
It's a pocket and all of their writers not
You got units in there, you got tables, you got titles, observations. Oh, you tabled your observations, that's fantastic. Qualitative observations?
I think this one had to be
That's so good.
like this is pretty, except that I don't like it too so much. I think we have this, but I don't think I want to do that.
You got some example calculations? Yeah.
Did I show you?
I have more than I can hold.
You've got the graph.
Yeah, I really like some of this, but I don't like
Yeah.
that I have it in there.
Good.
And I try to
Wait,
Good.
sometimes I got
You just reverse the. Yeah, you, how'd you do it in the first place?
That's where I got my spring flower dress. I just put all the flowers, but they're not
Well,
cheap.
you could,
They're decent, they just don't stay together very well.
yeah, yeah, good. I'm not saying I graphed it correctly, I'm just showing you.
They're so pretty, but they don't have the option to puff around there. I thought, oh, okay.
I would
oh,
say,
Eric,
that doesn't look like a curved graph.
No, but
That looks like a fairly straight line graph with maybe one bad data point at the very beginning and maybe two things.
oh god, there's this
Yeah.
monstrosity.
Look, all of our graphs are intended to be linear. So you might want to change your chart. Same with that one, same with that one.
Yeah, this, they all are showing.
Well, you can always take a polynomial curve and
Now
make it
this,
fit really
however,
close to the data.
is the best way to do it.
But the data is to be linear, it's just,
Again, not that I
it just has
don't
error
like
bars, so you get some deviation. So
I
don't assume algebraic. They all should be straight
Yeah, I
lines.
like that one a lot. No, not that one.
No, straight lines, line of best fit. Yeah.
It's too simple for me.
So there's a spot where you can make the trend line
This
a
one's
straight
it's
line.
got stars on it. Okay, There's,
No,
there,
no,
I'm
that's not
gonna
it.
go with the green and there's the green floral ones we'll probably come across and the green butterfly ones I really like.
Then if you got that, then that looks good.
That was great, 'cause I have some of
But
them, and then
you
they
can
also
change
have
the
stuff
trend
like
lines
this,
to straight
where I'm like, why would I do
Okay.
that? Wait, is that the one I did? Yeah, that's the one I was talking about. That one, and then there's another spaghetti strap one, it's like, another green one that I like.
Okay, that's a free
And sixes, yeah, this is like my favorite, it looks like the formal dresses.
Well, you mean like your data? Your data will naturally have sig figs because that's what you're recording and you measure. So like,
The lowest number of significance. This would be pretty for top.
oh, so when you
I don't like
calculate
the
something,
tops
it should go with the sig figs from your data. Yeah.
But there, oh, okay, some, I kinda like the, but they're all the
Okay. Good.
then I don't. I'm just trying to think of things. Where do you
Right. What do you have to do to change F
Oh,
equal
yes,
2 plus to F
absolutely.
equal 3
I can
plus?
just absolutely fully feathered.
No, you never. That's nuclear. You're adding protons. That's really hard.
Oh, or take away electrons.
Take away electron. So you have to take away one electron.
Okay, not something
Whereas in
I've
this
heard
one,
of,
what do you have to do with those
but
electrons?
something I would wear just like formals, definitely.
No. Well, nuclear, if you smash them together in a
I
particle
would wear
accelerator.
this as like formal.
I did that.
Because I only have one.
Well, that happens in our sun, so naturally it happens all the time.
Sometimes they're
It's the single most common reaction that happens in our solar system.
Why don't we do it? We should do it again.
If we could make a fusion reactor, if you make a
You know
fusion
what?
reactor, you will have solved some of the world's energy problems. There's some people who are going to be taking advantage of you, so just bring me your plans, and I'll make sure you get what you deserve. Yeah, much
Why don't we?
faster.
Well, I mean, like the equations. Like, why don't we write?
What do you have to do? What are the bonds doing? What are the electrons doing? Yeah,
Ions, and then it comes to another color.
yeah,
It's still, what's on this one?
yeah. But it's neutral. So how complicated was that compared to this?
This is the best way to.
Right. Which one was faster?
This one.
There you go.
So which, right? But for.
All the way around the
What is So the last question is this one. You could have a
You have a bunch of rates for that reaction, right? Go to your data for part four. Oh, but you now know how to calculate the rate, right? So you just do it, you calculate the rate, and then you would divide one by the other to figure out the factor by which it increased.
And for the first one, I put A because we're not dividing by anything, so there's no great factor of
Right, for the first one, yeah, because you're not comparing, yeah. No, the only thing is that your rate here, they should go up, not down. Did you have, where's the rate? That's seconds to minus one? Seconds?
1 over the time.
Yeah, and that's the time, right? Right there?
Yeah, that's the time,
So,
but in the calculation.
1 over 30 will not equal 153. That's what seconds to minus one is. 1 over the time. Yo. Where's your example calculation? Yeah, you don't, it doesn't tell you to put the molarity over top. It says the units are just seconds to the minus one, not molarity to the minus per second, just seconds to minus one. No. Yeah.
Yeah, it's all.
So that also might be why your graphs look a little off. But after this, just imagine how good you're going to be at labs using those sheets. I'm so impressed. Well done. Excellent job. No. No, not right now. I think my 5 minutes is up.
Wait.
Yeah?
Wait, all the data you took in the last one? Oh, and it all came out wrong.
Potential plus kinetic.
He's like, oh, it's wrong.
Sorry, what?
He's like, it's just wrong.
Enthalpy? Yeah. The enthalpy is the change of potential energy.
How long did it take you to do all that calculation? Wait, is it?
No, it's a change of potential energy. Show me. Because you can get it from solely the change of potential energy. Because if you go from here to here, it increases by a set amount.
I might have just still remember from table 3, I might have put your data because I didn't get it.
It's okay.
I can cite you though as my source.
I'm so mad. I'm fuming. It's been just a different color. They don't have to cover
With all of this.
Yes. I'm training myself.
I literally have a moment right now. I'd be screaming out.
Right, but when you're talking about the delta H, the change in enthalpy, you can measure that using the potential, how much it goes up. If you drew a kinetic energy graph, you could also measure it on the kinetic energy. Enthalpy? This would be fine on the test. But you are gonna see potential energy graphs and we've been drawing far more often. Yeah, it just has that. Because that's all you'll see. Ever. Because you can measure the bond energy, and that's potential energy, so something you can easily measure. So that's what all chemistry diagrams tend to be. Okay, that was more than 5 minutes. Let's continue. More knowledge. So this is just a summary of what we did. You write the overall reaction. We cancel all the substances that occur on both sides. These are the intermediates. So this is just a summary page, so you have it in your notes. Catalyst appears first on which side? reactant side. And then on the product side. So, we're going to define a catalyst. A substance that lowers the activation energy of a reaction and therefore has an alternate reaction mechanism. And what I am going to draw is starting, I'm going to put in some dotted lines so I actually can draw. What are you doing? Okay, so for our first one, let's start at 50. I'm going to go up to 250. No, that leaves me too much. Start at 100 so I have somewhere to go. Up to 250. Down to 50. There we go. This is the uncatalyzed reaction. And now in red, what would the catalyzed reaction look like?
Quicker.
You've answered. It would be quicker, but what would it look like on the graph?
Lower activation.
Lower activation energy. It could also have 2 steps, 3 steps. It could be lower. I'm going to make it look like this. So it's going to be that much. Now, would it end up in a different spot or the same spot? Same. So, delta H uncatalyzed, delta H catalyzed, energy of activation catalyzed, energy of activation uncatalyzed. Fill in all of those values, please.
Does ours have to be the same as yours? Say my catalyzed reaction doesn't go as high. Is that
Oh, I'm going to ask you for the numbers, so I'm going to use the numbers that I have up there. And I'm going to ask people.
what's that changing H of catalyzed?
Delta H, uncatalyzed and catalyzed.
Wait.
No, this is A block. So let's see. Luca has decided not to come.
I think she's sick now.
Sure. Sick. Heckling is forbidden.
Okay.
Okay. Person up, Martin. What is the delta H of the uncatalyzed reaction?
Gonna keep the stack. I'm not 100% sure, but I believe
Okay.
that it is 200 plus 200.
Plus 200 kilojoules.
Yeah, so I remember.
And where did you draw that on the graph?
Um,
What part of the graph is that?
just like from the end to the from the end. to
Yeah,
the-
this end, yeah,
No, the product end
yeah.
to the top of
To
the
here.
analyzer. Yeah.
That's
Ah.
wrong.
Well, I didn't draw it directly there, but like
No,
that's the
that's not
the
right.
height.
Okay, so
Objection.
so the next question, what is delta H? So,
Change in the
Felix?
It's minus 50 kilojoules.
No. What is delta H was the question to you.
It's minus 50.
No. What is it as a concept?
It's just the starting point to the end point.
Starting point to the end point. So it's
it's
from
gonna be
here
that blue line
to
the
there.
oh bet.
So then what would it be?
Minus 50 kilograms.
Then it would be minus
The
50
up and down
kilojoules.
cancels out more too, so you don't have to-
So minus 50 kilojoules. And Inara, what would be the delta H of the catalyzed reaction? Negative 50 kilojoules. Does using a catalyst change the reaction? No. So the delta H is going to be the same. What is the energy of activation, Felix, for the catalyzed reaction?
The catalyzed reaction, it is 150 kilojoules. Oh wait, okay. The activation energy is 150.
150.
Oh wait, no, it's 100.
100.
Wait, the uncatalyzed or catalyzed?
Right now, catalyzed.
Well, it starts at 100 and goes to 250, so it's 150.
With
Red ones.
Wait, black or red?
The red one.
red one.
The red one is 100.
Okay,
You're confusing me.
that's okay. The red one is the catalyzed one. So when I asked you catalyzed before uncatalyzed, perhaps. Well, it's probably good I asked it in that order then, just to be a little bit more confusing.
What the hell?
At the uncatalyzed, Na,
150 kilojoules.
150 kilojoules. $100 to $250. Okay. It's very loud out there. So, a catalyst works by providing a different mechanism. We've mentioned this before. What does it improve?
It decreases the activation rate.
Yep, but by what process? What is it usually improving?
Orientation.
Oh. The amount of collisions that are good.
Orientation of molecules.
Orientation of molecules. So their geometry. How they're held, where they are. Please do not discuss lunch, just before lunch.
It's a Philly cheesesteak.
We don't have grilled cheese day anymore.
No.
Sounds
Philly
awesome.
cheesesteak.
A what?
Philly cheesesteak.
Oh. You guys probably have never had grilled cheese day.
No.
No.
Oh.
Not once.
Why not? We used to do.
I
Why
mean,
did they stop?
they're
Grilled cheese day, every class was poised at 1:15. And then you'd run down and they would just have stacks of like grilled cheese and pickles and ketchup, and then people would like fill their plates with grilled cheese and fries.
That sounds
Why
awesome.
can we do that?
But also, there's no protein.
The reason we don't have grilled cheese day is because everybody was poised in their classes and would run down and like just eat so much bad fries and grilled cheese, like so much.
But they do
One
like
day,
pasta
like one day out of like the
I
month.
know.
Put a salad on the side. Why not just be like, have a generic Caesar salad on the side like usual?
I agree, but at some point they just stopped doing it. It became such a thing, and now they could probably do it again because none of you remember. Yeah.
Steak one where they just have piles of steak.
Anyway, I'm gonna move on. As you already said, if you improve the geometry, you have less energy required for a collision. This seems badly formatted. So if you could like fix it on your sheet as well. There you go.
Bro, what?
Yeah.
How do I reformat that?
Yeah.
Are you okay if we just leave it?
Yeah.
Just reformat.
Yeah. Just reformat it quickly.
I'll just move the letters. Yeah, hold on.
Oh. Now, you may get it to work by improving the geometry. How else can you improve a reaction?
More energy. Speed going like the speed that
Just, yeah, you can make it go faster. That doesn't improve it.
less.
How could we, when we were doing that reaction here, pardon?
Lower the activation
How?
by making multiple steps.
Multiple steps. So we can also increase the number of steps. Reducing the energy of activation overall. Word hard, morning. Morning. Is not morning? Is not. Afternoon.
Is it that we can go to lunch now?
Yeah, it's past
Uh,
noon.
We're done
Ahem.
constantly.
Just so I don't have to keep saying it, and I already basically yelled at the other class. You're a senior chemistry class. We will go to 115 each and every day. We will extract every piece of knowledge, and we will continue. Because otherwise, the end of the year, your final exam is on PLOs A through W, no matter how much you've learned. So if we skip a unit, I'll skip a unit and say, learn that section on your own. And then we'll just move on. You've got to know all the stuff for university. We are preparatory. Okay? Compare the... No. We have done something like this. But what I would like you to do is do it for both the forward and reverse reactions. So this is the forward reaction. And this one is the reverse reaction. Give me the energy of activation catalyzed and uncatalyzed and the delta H catalyzed and uncatalyzed. Yeah, reverse is when it's going backwards.
Whoa.
And the daughter is catalyzed, right?
Oh, my body's dumb. My body's dumb. No. When it goes forward.
And the daughter one's catalyzed.
You're catalyzed, bro.
You don't need to know whether the solid line or the dotted line is catalyzed. How do you know which one's
Oh, the
catalyzed?
catalyzed
Whichever one
one's
has
Catalyzed lower.
lower activation.
And if you just made a boneheaded mistake, realize that in October, a long time ago, I was going down a street where they really decorate for Halloween. And this one house had all these pumpkins out, and each pumpkin was lit up with a different color. And someone said, "How do they do that?" And I said, "Different colored candles."
Oh. Wait, what?
Exactly.
I don't get it.
I don't think it was that funny, but I'm glad it
Because you light a candle, it's not going to be a different color. That's why, Dylan. Just
think about it. Read an extra check.
I don't
Yeah,
think
we
you
can
have
also make
time.
it
I know, but it's not enough.
What if you made it?
Why didn't you- yeah, I'm gonna say question mark.
Because it's two, forward and reverse. Forward and reverse.
Wait, is it this? Oh, no, that's not the stupid upside down one. Which one's the stupid upside down one?
People seem to be a bit upset that half of this is the same. Should I change all the numbers so you didn't give me?
I already did it.
Because I told you so.
Not already done though.
I can make it like 2, 4, 6, 8.
I just go backwards. I go like tomorrow. You know what I'm saying?
Uncatalyzed is oh.
Yeah.
Oh, so this plus?
Got it.
Okay, I think that's enough.
Yeah. The solid, uncatalyzed solid.
First up, paying attention. Eshwan, EA catalyzed, 100 kilojoules. And James, EA uncatalyzed, 150. Delta H, catalyzed. This is all forward direction. Taylor,
Negative 50 kilograms.
Delta H uncatalyzed. Dylan,
Negative 50.
negative 50 kilojoules, so we should be noticing a pattern. Nicholas, reverse energy activation catalyzed, 150 kilojoules. Sabine, energy of activation for the reverse reaction uncatalyzed.
Well, I got 150, but I got 200 for the first one.
So now I'm gonna star that 200, 150, and we'll come back to it because I'm not checking it. I'm just accepting whatever anybody says. Gonna check it at the end. Chloe, delta H catalyzed for the reverse reaction.
Plus 50 kilojoules?
Plus 50 kilojoules, good. Sophia, delta H uncatalyzed in the reverse direction. Plus 50 kilojoules. And that's written incredibly badly. So, any other disagreements about any of the other numbers?
The reverse uncatalyzed.
Reversed uncatalyzed
Yeah,
The
it's
reverse
is 200.
uncatalyzed, so let's take a look. So, energy of activation, we're going this way for the reverse. The energy of activation catalyzed should be this. So that would be 50, 100, 150. So I think it is 150.
Yeah.
Does that make
yeah,
sense?
I just swapped them up.
Oh, okay. And then this one,
200.
2, 3, 4, yeah, you just swapped them. And then the conclusion of all of this, what does the catalyst do to the energy of activation? Lowers. Which means more reactants will have sufficient energy to react. Ahem, please don't do that. That is disruptive.
So Mathilda,
Why?
Like 22.
Oh, you already talked to me. Yeah, that's fine.
Class.
Yeah. Memory needs work. Okay. You have, much like we had before, this is like the Huber reaction. This is 3 steps. I haven't given you the overall.
Huber's already a class favorite.
Trace over it what the potential energy diagram for this would look like of the catalyzed reaction, knowing that this is it catalyzed. So this is it uncatalyzed, 1 step. This is it catalyzed, 3 steps. I want you to identify all the reaction intermediates, and I want you to identify any catalysts, and I want you to write out the overall reaction. So you're gonna have to add this up. Okay? So this is putting all of this together. Okay? And then exothermic or endothermic, and what is the delta H?
What is the thing that's already
Also, reminder, when's your quiz?
Saturday.
Monday.
Saturday.
Saturday.
It's Saturday. I thought it was Saturday.
Saturday.
What's today?
Yeah, it's here. It's DEF.
Why did they do that?
When did they send that email out?
Okay, they didn't send an email out, so check my school.
Oh.
It was definitely on an email.
Yeah, I was just told.
No, I'm saying you got him there.
Oh, curses, you're right. You should have had your quiz today. We could still have it.
No.
We got 7 minutes.
That's unfair. That's unfair.
Okay, then when would you think your quiz is?
Monday.
Okay, so,
No, it'd be Monday.
no, it will be Monday. Just keep in mind, I hate assigning things for Monday. Because the point is that you shouldn't have to study over the weekend. You knew it was due Saturday, so you were to use tonight and Friday night to study. It is on Monday. Do not complain to anybody that you have to study on Sunday. You are not allowed to.
What if we want to?
No, you're not allowed
We
to
study
on
tonight
Sunday.
and Friday, and then we're like, you know what, I feel like I'll just catch up a little bit.
No, I forbid you.
It's like constant,
Wednesday just to be sure.
All of your homework, even your English, no studying on Sunday.
The Sabbath. That's funny. That's really, really
You have to take English to graduate.
Who's your teacher?
What?
English.
Oh, Mr. Meyer.
Ah, yes. Tell Mrs. Woodmar, Mr. Neufeld forbade you from doing English homework.
I don't know.
How'd you do English? Bro.
Okay,
Awesome.
you're doing this. What am I sitting down for? Keep going.
I was in grade 7, we were like, you're smart. How to buy class
What?
I did pretty well. Then I switched schools in grade 8 and it was the worst.
That is, I was like, I even looked at the calendar. Did they recently change it? It's been like that all along.
I've done like all of them.
I must have just assumed and like, oh, that's what the blocks are. Yeah.
This is a trace over with the catalyzed.
Do you want to see us?
Yeah, you want to make it different. So that it's kind of, it's got 3 steps. I tells you.
Yeah, this one doesn't have the H. Is it?
I'm not gonna tell you the right answer. I'm gonna ask
I
you.
don't know where the catalyst.
So,
Yeah.
so how do you identify? Because we did that on the other diagram. How do you identify the catalyst?
It goes in on the
It's
reactor.
out.
Is on first year EDC students, is that not a big driver?
First year of anything is
But like especially UBC.
What's the reason? Like, goes out.
Like after looking at their work.
Their dorms, I mean, I've been in their dorms. They're not, they're just dorms. They're a little worse than their own dorms. On the other hand,
Wait,
you
worse
have
than
access to beer, so,
No reason.
yeah.
Mr. Neufeld.
Well, I mean, it's,
Do we know energy technically?
No, you just know, and there's one from this
let's share.
So you just have to make it relative to this? Correct.
Oh, Carlos.
Yeah.
That is no space at all.
I can't find it. That's
There's definitely a catalyst. You also have to identify the reaction intermediates. Go back to our other reaction notes.
Vancouver overall.
I have 2 questions.
Yeah?
Mr. Neufeld.
Your parents are just getting casual calls that have a special living.
Yeah, that looks good.
Oh.
Yeah.
Oh, I don't ask me that. Chemistry now. I like crazy.
Or they might get out.
That was good. Yeah, I'm gonna have to put all that, I just haven't had time yet. Yeah. What are you doing? No, let's go, let's get Tracy.
We know which one. Could you please check
Activation and
Is this one of Tracy over top there to go in? Why is it? Yeah, using the same graph, but shouldn't be exactly the same. Yeah, that's an analyzer.
It's not the iodine.
Yep. No, you're confused. We've already done this. But, ask me for mercy. Well, I want you guys to consult me. I'm just gonna see if
There's no
there's a catalyst.
Is it water?
It might be.
It has to be.
I'm not gonna tell you. I want you to say whether or not it is. If not, define it. Only thing I'm telling you is that there is a catalyst.
How do we find out if it's like 3 ions all in? It has to be correct.
We all know.
So it has 3 steps.
Yeah, one.
And which step is the slowest step?
Here.
Okay.
Third step is
Okay,
well, like intrinsic.
I'm gonna give a little bit of advice that I was given in university for understanding chemistry questions. We've got a lot of information. And whenever we would give answers that were incorrect, sometimes my professor would write this beside our answers. Does everybody know what that stands for?
Yeah.
Read the fine question.
Yeah.
Okay? So if you're confused, reread this, because during the test or quiz, I won't be there right away from the X. I'm trying to get you away from asking me every 3 seconds. I'm just going to look to see if you're on the right path, but you do have to read the fine question. Fine question. Obviously, the fine question. No, please stop that. Oh! Wait! That's not good. Eshwan, see me in the house for some chores. I would never swear in this class. Okay. Oh!